When you add and subtract, okay, you need a common denominator. So adding and subtracting in fractions is actually harder than multiplying and dividing. So you do not need a common denominator when you multiply and divide. What's the common denominator for 4 and 5? 20. So, or in other words, 4 times 5 is the common denominator. So when the denominators don't have anything in common, like nothing goes into 4 that also goes into 5, right? When they don't have anything in common, the common denominator is just one of them times the other. But remember, when you multiply the bottom times 5 in a fraction, you need to multiply the top times 5. Or the bottom times 4, the top times 4. So this becomes 15 over 20 plus 8 over 20. We did that once upon a time. And then when you go to add, what happens? You add the top and the bottom stays the same. So it's just like 23 over 20. Now if this could reduce over here, you do need to reduce. Can we reduce over here? No. This does not reduce. That's a multiply thing. We don't want to reduce here because we need the common denominator. Anyways, but if this does reduce, you need to. Okay, now that's what we're doing, except for it's polynomial form, not number, not just normal fractions. Number 1, it does not start off like that. 3xy squared and 15y3. Okay. So, for the number part, these are both just one term, right? So for the number part, what does 3, the directions are find the least common multiple. The reason they're asking for the least common multiple is because later on we're going to be doing fractions, and they're going to say you're going to have to find the least common denominator. So that's why it's the same thing. Least common multiple, least common denominator, same thing. Okay, so what do 3 and 15 both go into? The smallest thing they both go into, 15. It's not what goes into them, it's what do they go into. 3 goes into 3, 6, 9, 12, 15, right? 15 goes into 15. So 15 is the least common multiple of 3 and 15. Now, for the x's, well, this has an x, this one doesn't. What does x go into? X. Okay, there's just one x. Okay, here's the more important part. What does y squared and y, what do they both go into? Y squared. Why didn't you say y to the third? Okay, because all you need to turn this into a y squared is times y, right? This is already y squared, so they both go into y squared. We're not adding these together. We're saying what's the smallest thing they go into. So here's kind of a very important thing for today. When you're finding the least common denominator, least common multiple, you want to use the most of each kind of variable, each factor. So what's the most of my y's? 2. Okay, so I use 2. Because both of these can be turned into y squared. Okay, for the z's, what's the most of my z's? Z.
Are there going to be any ors?
Ors?
Like, in geometry, we did and or.
No, I don't know. Why would-
Ken, you're stupid.
Oh,
How do you not know these are great?
No, there's no ors.
Oh, no, that's
Okay, actually, I'm going to go ahead and do number. Like I said, this one's hard. We might, when we come back from the break, we might have to do like a worksheet on this too.
So are you not going to do three?
Huh?
Are you not going to do three?
No, I am. So on this one, what do 4a plus 16 and 6a plus 24 go to? Well, basically the rule is, if it can factor, you need to factor it. So you can see what they have in common and what they don't. So how can this one, these don't factor because they're just one term. These can factor because what can you do to this? Take a 4 out. I divide both of those by 4, I get a plus 4. Okay, what can I do on this one? Take a 6 out. And I'm left with a plus 4. Okay, then after you factor, you can start asking, what do they have in common? What do these both go into? So you kind of break it down. So what do 4 and 6, what's the smallest thing that 4 and 6 both go into? 12. Okay, they both go into 24, but the smallest thing they both go into is 12. 4 goes into 12. 4 does not go into 2. Okay, 2 is not the right answer. 4 goes into 12. Okay, and then they both have an a plus 4. So remember on the last problem how we said like who has the most y squareds and or who has the most y's and we use that, y squared. So remember how we've been thinking of a plus 4 as like one thing this week when we cancel stuff out. So you need to think of a plus 4 as one thing. Like this cancels out, but this does not cancel out. Okay? Because basically adding and division do not cancel out, that's why. Okay, so just like when we did these individual letters, we used the most of each. So who has the most a plus 4s? Well, it's a tie, they both have 1. So you have to use 1 a plus 4. And we could multiply that back out, but there is no need. We're just going to leave it like that. All right, does that make sense? So when we were doing the numbers, we just said, what's the smallest thing 4 and 6 go into? The answer is 12. When we went over to the letters, or the factors in this case, we said who has, to find the least common denominator, who has the most a plus 4s, or who has the most y's. Anyways, that's how it works. Okay, does number 3 factor? Does it? Is this a square minus a square? Almost. If this was squared, or if this one was squared, it would. That would be a square minus a square. But that is not a square minus a square, so it does not factor. So what's the common denominator going to be? Common multiple, least common multiple. No. Okay, we're thinking of this as one thing and this is one thing. They're two totally different things. They have nothing in common. So, who has the most b minus 4s? Well, one of them is the most. Who has the most 4b minus 1s? That one. So that is the common denominator. Common multiple. Remember my example at the beginning when we had a denominator of 4 and 5, and what was the least common denominator? 4 times 5. Okay? Same thing here. b minus 4 and 4b minus 1 aren't really related in any way. So the common denominator is just those two multiplied together. Okay. Numero 5. X minus 2 squared. Can we factor x minus 2 squared any? No, it's already factored. This just means x minus 2 times x minus 2. It's already factored. Can we factor the other thing, x squared plus 5x minus 14? Does that factor? Yes, because it's 3 terms. Okay, so the question is, what multiplies into negative 14 that adds up to 5? 7 minus 2, yes. 7 minus 2. Okay. And then we're just going to kind of go through. So, doesn't really matter. I'll start with x plus 7. Who has the most x plus 7s? This one. So we need 1. Okay, who has the most x minus 2's? This one, so we need 2. I'm just going to write like that. X minus 2 squared. Okay, let's stop for a second. How is this a common multiple of this and this? What would we need to multiply this by to turn it into this? X plus 7, right? This is just missing an x plus 7. So if we multiply by that, it would turn into this. What would we need to multiply this by to turn into this? X minus 2. Okay, and then that would turn. So these both can multiply into this. That's what we're trying to get to happen. What can both of these things multiply into? That's what we're going for. So, but the question I kept asking is, who has the most? So we got to use like one of everything, but whoever has the most of that kind, that's what we're going to use. Because for this to go into it, we have to have at least 2 of them. There, okay. On number 6, the second thing is b cubed minus b squared minus 20b. What can we do first? What can we do on this? Right. You should always check, can I take something out? Usually no, but sometimes yes. So you should always check that first. And then after you take something out, sometimes there's other factoring that can be done, right? So this thing in parentheses is a 3-term, b squared b number. So what multiplies into negative 20? That adds up to negative 1. Minus 5 plus 4. Okay, so when you go to find the least common multiple, you're going to say who has the most b's, who has the most b minus 5s, who has the most b plus 4. So at least one of these is going to be part of your answer. At least that, at least that, at least that. It's got to be more than that though. So you still have to factor the b squared minus 25. But that's how it goes. Okay, number 7 is actually really easy. Okay, why is this one easy? It already has a common denominator, so no problem. So we just do add the numerators, right? 7 plus 6, 13 over 5y. Now, we should also check, does this reduce right here? 13 and 5? No, it doesn't reduce, so that's it. No problem. Yeah. Okay, I do want to look at 8 though. So 8.
Yeah.
Is it a pep rally or just a waving goodbye kind of thing?
I thought it was a pep rally.
I
I think it's a
There might be a.
It's really not.
There's band, but we're gonna be outside basically. It's not cold.
Grow up.
Do I go?
I remember that.
Get on Katie's level.
Caleb. Then I'll see.
Alright, here's some.
I'm gonna miss you guys.
We were like, oh,
We're like,
we
come
don't
here,
know.
right?
Yeah, going inside.
Guys, I already didn't understand this.
My
math. I
handwriting
don't know
isn't
how I
that
understand
bad.
it even more.
That was the best.
Did you bring your instrument?
No. I was in that band.
I know that.
Okay, if you don't have an instrument, should you be leaving then?
Do you have one in the
I-
closet
Yeah.
back there?
So you're using a backup trumpet or whatever?
No, just my usual one. I just keep it in the thing.
Well, then why did you say you didn't?
Well, I just asked if I brought it. I brought it with me. She's not gonna write it. It's not my fault. That's a stupid question.
Hey, you haven't taken a sip from that water. Maybe a little sip. You opened it just.
There he is. There she goes. There she goes. There she goes. Oh, okay.
Okay.
There's the final one.
8,
That A looks
Wait, what's
weird.
Which one?
The
Oh.
A, look at that.
It looks like a
Looks-
Q.
yeah,
It does.
It's like a Q.
Or like it like got
Oh,
stuck
it's
by
a weird
line.
line.
Fix it, Mr. Jordan.
Come on, guys.
The other one's so cute.
That works.
That looks like that symbol. It's like
That
that
was
symbol.
a
Okay.
Those are cute.
How
All
does
right.
that look like a bat symbol?
So,
I don't know.
they have the same denominator, so what am I gonna do?
A.
A plus 1, does that mix? No, it's not. Okay, does this reduce? Okay, Shannon said it. If you see this right here, a little bell should go off in your head, because this is a square minus square. Because what squared equals 1? 1 squared equals 1. So it factors. Square minus square. So what's the square root of that? A and A. What's the square root of 1? 1. So it's minus 1 plus 1. Now, if this didn't reduce, it wouldn't have mattered, because maybe that's the simplest we can get. But because this reduces, it matters a little bit. So you need to reduce it as much as you can. Now, if both of those A plus 1s cancel out, what's on top? 1. Yeah, it's kind of like when you do 3 divided by 3, it's 1, right? Not nothing. So anyway, there's still a 1 on top.
You should do 4 with us. You should do every single one.
Cause I don't know how to. I don't understand 4 either. I don't understand.
You're going to have to factor both of those. And then you have to use the most of each kind, which the most might just be one of them, probably.
Yeah. Do that.
Can there be more than 2?
Could be.
be 3 with this? Yeah.
Okay, let me go back. So on this problem, this one had 2 of these, this one had 1 of these. How many did I use my common denominator? Common multiple. I used 2.
I had to take over your page.
But if there's 3 different kinds,
Oh, well, yeah, it keeps going, it can keep
it just
going.
keeps going.
Yeah, it can keep going.
Okay.
Yeah, I need Still wait.
I love one. Yeah, they all would be a different result.
Oh, well, I was gonna say I'll give time to do the evens, but we might have to do it tomorrow. I wanna try to get, these actually don't take very long until like you get to the part B. No.
This is my first time ever sitting here.
Let's do the work. Cause I was gone yesterday, and yesterday was time I meeting on Monday
Today.
You were gone yesterday? Oh, but it was an activity absence, so no.
I was on a trip.
So what'd you say?
Not for activity absences.
I saw when I wrote this down.
Okay.
So it was over here.
And then you used to sit up here, right? I think
Yeah, well,
it's
let's just
so-
do
Like it says, what time?
It'd be like an activity absence.
So it would count towards like our 3 days that we can have.
It's not like a sick day, no.
I was.
So yeah, if you're gone tomorrow, this is still due on Wednesday. We'll get most of it done, well,
So we just have to like.
We're out with it.
okay.
Yep.
Any ideas on this one, guys?
Just do that minus
Make the
Kind of,
boy-
yeah.
Divide by.
Flip
So
it.
when you have 2 times negative, or divide by -3, that basically makes the whole fraction negative. So it's just like minus negative 2/3. So it's just plus. You like that one? You like that? Okay, so it's just x squared plus 2 over 3. Is that going to reduce? No, definitely not. X squared plus 2 does not factor in anyway. It's not a square minus square. Can't take anything out. Nothing. All right. 5/8. These actually, the odds especially, the odds are a little bit easier on this one. They go pretty fast on this part. Okay. This is the first one where we actually have to find the common denominator. What is the common denominator going to be between these 2? No.
That's a
What, okay, because what would we have to multiply a by to turn it into this?
I have a question.
Shh, listen, just listen. Let's say a plus 6 was the denominator. What would we have to multiply a by to turn it into this? Okay, it can't, it's not it doesn't work. There's nothing we can multiply this by to turn it into that. So, a is like its own thing, it's like a plus 0. There's nothing, whatever a is, a plus 6 is just gonna be something totally different. So, you treat it as its own thing. So who has the most a plus 6s? That guy. Who has the most a's? That guy. So we just need one of each.
Mr. Jordan, I think that's a B.
That's a 6 on top. I'm talking about the denominators. Common denominator.
Oh, no way.
Uh,
Oh, yeah, on the bottom.
That's a B. I thought you were talking about that
Doesn't
6.
change much though.
Okay, yeah, same thing. It's the same idea though.
It's like just.
You're like mean about it.
He usually asks me questions on evens when I'm trying to explain an odd, which would, anyway. So, what is this? This is the first time we've had to do this. What is this missing from the common denominator?
B.
It's missing an
A.
a. So we're going to have to multiply this fraction by a. If you multiply the bottom by a, you have to multiply the top by a. Okay, what is this denominator missing from the common denominator? A plus b. So if you multiply the bottom by a plus b, you have to multiply the top by a plus b. Okay, now the good news is the denominators don't really do anything, right? When you have a common denominator, it just kind of stays the same. So we don't need to do anything to the bottom. We just need to simplify the top. So basically what's going on the top is this. So that's kind of the problem. We just need to simplify that stuff. So notice that minus comes with a 6. So you got to kind of distribute. Whoa. You have to distribute that like negative 6 on that. So what's 5a times a? Minus 6a minus 6b. Okay, does any of that add together? Can we simplify this anymore? No, they're all different. Does it factor? Could we factor it and try to cancel that with the bottom? No. It's very close to looking like it does because it goes a squared a. If it just had a minus 6 there, maybe it could factor, but no, with that b, it kind of screws it up. So no, it doesn't factor, we can't reduce, and that's it. That's the answer, that's all we can do. Not a fan?
No.
Okay, 13, I skipped 13. 13 is 5. We're in minus 5 plus 2 over 5 minus 7. Okay, does this have a common denominator? No. However, they are related. You guys remember we did this a couple days ago? Like, does that reduce? Okay, if I subtract things in opposite order, what's 7 minus 5? What's 5 minus 7? Whoops, 2 and negative 2. So, do they reduce? Yes, but they leave a negative behind. They're opposites of each other. They're opposites. Like 1's 2, 1's negative 2. So, one way you can think about it, if I took a negative out, like I divided a negative 1 out, this would become negative 5 plus n, which is the same thing as n minus 5. So they're opposites. So if I take a negative outright of this, it just turns into an m minus 5. But I've got to put the negative somewhere, so the fraction just becomes negative, basically. So instead of adding 2, we're just going to be adding negative 2, we're going to be subtracting 2. So it's 3 over m minus 5. So 14, well, what about 14? Pretty much the same, isn't it? So 6 minus c, we can take a negative out of that, and it would become positive c minus 6. But where does that negative that comes out, where is it going to go? Well, the fraction will just become negative. So you're going to have minus negative 6 instead of just minus 6 on top. Got it?
Yeah.
6 minus c turns into c minus 6 when you take a negative out. But you got to put the negative somewhere. You can't just throw it away. So the problem will become, instead of minus, you know, this fraction will be minus minus, so it'll become a big plus. So just add. Yeah, we probably better stop. It's like the only day where you guys are like behind the other class.